Good day, this is the Professor, CBMD PhD, and today's Thursday, April 13th, 2023. It is 6:27 and 8 seconds, a.m. Eastern Daylight Time, and today's research, light pollution. So let's hop to it here. Light pollution makes 10 mosquitoes. Biting season. Study suggests light at night disrupts insects. Winter dormancy. Date April 11, 2023. Source: Ohio State University. A new study is finding that urban light pollution may disrupt the winter dormancy period for mosquitoes that transmit West Nile virus. Could be considered both good news and bad news. The good news is that the disease-carrying pets may not survive the winter if their plans to fatten up are foiled. The bad news is their dormancy period, known as diapause, may simply be delayed, meaning they are biting humans and animals longer into the fall. They see the highest levels of West Nile virus transmission in the late summer and early fall in Ohio. If you have mosquitoes postponing or delaying diapause and continuing to be active longer in the year, that is a time when the mosquitoes are most likely to be infected with West Nile virus, and people could be at greatest risk of contracting it. The researchers are among the first to show that artificial light at night can have a significant impact on mosquito behavior, including effects that aren't necessarily predictable. They are finding that the same urban light at night can have very different effects under different seasonal contexts. As diapause for female northern house mosquitoes, Culex pipiens is not quite a winter slumber, but rather a period of dormancy when the insects live in caves, culverts, sheds, and other semi-protected locations. Prior to winter's arrival, mosquitoes convert sugary sources, such as plant nectar, into fat. As days get longer, females begin foraging for blood meals to enable egg production. Some get infected with West Nile virus by feeding on infected birds, and later transmit the virus when they feed on people, horses, and other mammals. And this study builds upon two previous findings from the laboratory. Their dissertation found that circadian clock genes differ between diapausing and non-diapausing mosquitoes, strongly suggesting that daylight dictates when diapause should start. And more recent work, led by the researchers, found that female mosquitoes exposed to dim light at night averted diapause and became reproductively active, even when short days indicated they should be dormant. The researchers pursued both lines of inquiry, comparing daily activity and nutrient accumulation by mosquitoes reared in two laboratory conditions: long days mimicking the insect's active season and short days that induced dormancy with and without exposure to artificial light at night. The study provided more evidence associated with a circadian pattern to mosquito behavior, showing that insects' activity decreases during diapause, but the circadian rhythmicity of that activity is sustained even during this dormant period. The introduction of artificial light at night was found to affect those activity patterns and to influence mosquitoes' acquisition of nutrient reserves needed for fattening up and weathering winter temperatures. Exposure to light pollution suppresses the amounts of water, soluble carbohydrates, sugars that are an essential food source during winter that were accumulated by mosquitoes in both long and short day conditions. The patterns of accumulation of sugar glycogen were reversed by exposure to artificial light at night. Under normal conditions, non-dormant mosquitoes had lots of glycogen in their bodies, but diapausing bugs did not. But in mosquitoes subjected to light pollution, the long-day mosquitoes didn't accumulate much glycogen, and short-day mosquitoes showed an increase in glycogen accumulation. The researchers observed consistent trends in activity-related effects of light at night, with slight increased activity among the dormant mosquitoes and slightly suppressed activity among long-day mosquitoes expected to be busy looking for food. Though the findings weren't statistically significant. The combined observations suggest light pollution causes mosquitoes to ward off diapods, perhaps by scrambling signals from their circadian clock. And this could be bad for mammals in the short term because mosquitoes are potentially biting us later in the season. But it can also be bad for mosquitoes in the long term because they might be failing to fully engage in preparatory activities they need to survive the winter during diapods, and that might reduce their survival rate. The researchers plan to carry out field studies to see if these laboratory findings hold true in the wild. And this is the Professor of Microbiology, Bioinformatics, Pathophysiology, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.